The reason we have a gap here is because you want to let the butternut squash cook for a little bit. It takes a little bit longer than a lot of things, so you just need to let that cook just for a few minutes before you throw everything else in. Peppers in.
Yeah, hi everyone. Hope you people are having a great session today, already attending such amazing workshops and sessions which were lined up. And today I'm here to talk about best practices for securing our Kubernetes cluster. It would be a 20-minute session with a 5 minutes Q&A at the end. So just to introduce myself, I'm Mamta, co-founder of TechScalable. I work as an enterprise cloud architect and certified trainer by Red Hat and Microsoft. We would be discussing about security aspects of Kubernetes. So if you look at Kubernetes security, it's based on 4 C's of the cloud native security. We can think of Kubernetes security in layers. There are 4 layers as shown in the picture: cloud, cluster, container, and code. And therefore it's called as 4 C's. Each layer in the model builds on the next layer. So for example, cloud security forms the base layer, cluster security builds on that, followed by the container security. Cloud. If we look at that cloud security aspect of it, then it's very important, just give me one second. It's very important that the underlying infrastructure on which the clusters are deployed lays the foundation of Kubernetes security, irrespective of whether the cluster is deployed in an organization's own data center or it is with a cloud provider. Best practices should be followed. There are a lot of aspects with respect to the physical infrastructure security aspects, like network access to the node should be controlled in a better way. We should not expose the APIs to the external world. We need to control the set of permissions which we are giving to the control plane and the nodes. If we look at cluster security, securing the cluster is done in 2 different ways. The configurable components like the Kubernetes APIs, which we have, through which we interact with the cluster, that can be secured. And the security of all the applications that are part of the cluster, that is also important. If we look at the APIs, we can secure them with role-based access control. RBAC has been there in Kubernetes from 1.6 version. So when we are using RBAC, role-based access control is called as RBAC, we prefer to have namespace-specific permissions rather than cluster-wide permissions. Even while debugging, I don't think we should grant cluster-level administrator privileges. Authorization is one part, authentication is one part. Authorization says who can do what in my cluster, but who's that who? How do we authenticate that? That can be done with any third-party authentication provider. Like, for example, if I would like to integrate GitHub with my cluster, I can have multi-factor authentication as well enabled. We can also have OAuth 2.0 connectors like DEX integrated. And we just need to ensure that the Kube API server doesn't change when users are added or they are removed. And I don't think we should actually manage the users on the API server level. We also have secrets. Secrets are useful for storing and managing sensitive information. By default, when we are storing anything in the cluster, they are unencrypted. For security purpose, we can go ahead and encrypt that. In this aspect of cluster, network policies, which is not there in the slide, that is also very important. Network policy effectively controls the traffic flow at the API address or the port level of the cluster. They should therefore be properly configured for effective security. Then we have TLS. TLS for Kubernetes in Grace. We can secure what is coming with the help of a TLS private key and a secret, the certificates and all we can have in place, and we can secure the incoming messages to our cluster. So continuing on that, the next one would be the containers aspect. So we have covered cloud, cluster, and then containers. Best practices for containers design consists of starting with the smallest code base possible, avoiding granting unnecessarily privileges to the users that are running inside the container. If you look at a container, by default, we become root user. So root user has privileged accesses. And if someone enters my container, it would be having a lot of capabilities and can play around and screw up my entire system. So we just want to make sure that containers are scanned for vulnerabilities at the build time. Container vulnerability scanning and OS dependencies, securities, those aspects are very important. So when we are building containers, we can scan for known vulnerabilities, and we can even scan for images. We can sign them. We can enforce that the images which are being created by us, they are of good quality. They don't have any vulnerability. They are pretty secure. We can use good container runtime, which has stronger isolation. Like container runtime classes can be used to provide stronger isolation at the runtime. Then comes the next aspect, which is nothing but the code. Application code is one of the main attack surface in Kubernetes environment. We can access over TLS. If we need to communicate by TCP, like we need to go with TLS handshake. The number of ports we are opening for the external communication, that should be well thought and opened. We should strictly open only ports which are necessary for communication. Then we have some third-party dependencies and all installed in our containers, which can, I would say, it can have a huge footprint for vulnerabilities and unsecure stuff. So most programming languages have these tools which can do this automatic check and all. We need to use that. With respect to the code checking, static code analysis tools like Veracode, Sonar are very important because they analyze the snippets of the code for any unsafe coding practices. And where possible, these checks should be done using automated tooling. In the CI/CD pipeline, you can integrate these checks and just make sure that our code is safe and it's not having any common security errors. Then with respect to dynamic probing attacks, there are a few tools that can help us in assessing, and we can attempt some of the well-known, like against a service, some well-known attacks like OWASP-Z. Those type of tools can be used to assess that. Going on to the next point, what are the common security mistakes which people do in their cluster? Applications which are running, they are often made of edge services. They are designed to be open to the internet. We need to expose them for external connectivity. When we do that, strong authentication and access control is needed so that when that outsource or exposed services interact with the internal backend services, they are the trusted services. We only receive messages to the internal services from trusted services. Unfortunately, what happens, accidentally we expose these internal services to the internet and potentially give away some sensitive data most of the time. We can think of accidentally exposing our internal services, like if we don't have a load balancer and all in place, you expose your application directly. We can use load balancers, we can use node port, we can use ingress controllers, we can have certificates installed in them, we can authenticate what is coming inside our cluster and then allow them. That is one of the best things to have. So most of the time, when a developer is using any Helm chart or is using any template, what happens? Those templates are already having inbuilt load balancer type of service being created, the Kubernetes service I'm talking about. And we just ignore that fact and we go ahead and deploy our application using that Helm template, for example. So it's very difficult to figure out those mistakes because these load balancers would have public access, and then our application unknowingly is getting accessed on the outside world. Whenever we have accidental exposure of the workload, unauthorized network access can be stopped using network policies. We can even try out that. Like, I would ensure that I will only open ports which are good. I would not expose unnecessarily any application to the internet, but I should also be ready with few network policies, which will help me in policing what is coming, what sort of communications are happening within my cluster from service to service communication type, what exactly is going on. That becomes important. So we need to have that in place. Network policies are one of the key important parts. No network policies, no firewalls, that would actually make our cluster very vulnerable. Then we have containers. In containers, if we create privileged containers, how much of privileges do we need to provide to the users, which runs inside that container is important. It could be a possibility. What happens when we create a container runs, instantiates as root user, and then switches to a specific user. So if I give some privileged access to the user and the container is an ever-running process, then whoever enters the container gets that access inside the container and can intrude into my host machine and then play with my kernel parameters and all that stuff. So that becomes one of the important key aspects. So some containers may need special access to the underlying host or the network. The easiest way would be only for those containers enable privileged access. And there is something called as capabilities in Linux. Whatever capability you need, only enable that particular capability. Like, for example, capability of system time change or capability of network settings change is not needed by every other container. If a specific container needs that, I can enable just that capability in that container. So when we think about these things, then our control given to the user inside the container is very limited. And it would not be having abilities to break through everything and get inside our host. One other common mistakes which we do is sharing sensitive host folders inside the container. Mounting the host path file system with containers is one of the common practices. What we are mounting inside the container is very important. That gives us a flexibility to have persistency in our containers data, but what we are mounting is important. If we mount some path like /etc Kubernetes, if I'm mounting, my entire Kubernetes configuration gets mounted inside the container. So that would be a foolish thing. Because we are talking about containers, we are talking about code. When an organization is moving towards Kubernetes, most of the time, from the beginning, from the start itself, we need to lay the boundaries, what the team can do, which all things it can be exposed. That has to be well thought of. Avoiding exposing any Kubernetes node to the internet, or how we would be deploying this application in the cluster, that has to be well thought of. So every small microservice, because it's a distributed system, right? In cloud native, we talk about microservices, we talk about distributed architecture. It's just not one microservice that you would go ahead and deploy. My application would be broken down into multiple microservices. So that becomes very important. We need to categorize which applications or microservices would not be externally exposed, which would be externally exposed, and then take a decision on that. So that becomes one of the key aspects. Then, if we look at the best practices, end of the day, disabling public access to the nodes of the Kubernetes, whatever nodes we have, the worker nodes where the application is deployed as containers or pods, if you say in the world of Kubernetes, or how we are going to handle the master nodes communication. We need to not give them external connectivity. We need to safeguard or disable public access to the API control plane. If we look at the Kubernetes architecture, etcd, our database, which stores all the information, the workload information, the cluster information, the cloud's metadata, everything persists in etcd. So I would say encrypting it or having this using vault type of service, key management services like HashiCorp's Vault and all is very important. Enabling encryption as rest, backing up, and those backups also would be encrypted. That becomes very important. When we are securing our containers, then role-based access control, secrets, those things are very important. When we are talking about communication across containers, then how this network policy helps us in defining which container can talk to which container. For example, a database container is there, which should accept packet only from the front end. It should not go ahead and accept packet from any other container running in that cluster. So that is very important. And when we, as I said, we should segregate what sort of workload would be sensitive workload, which we would not expose to the outside world. Scanning of images like Microscanner, Claire are some tools which are very important. We can use, for segregation purpose, I remember one more point is that we can use namespaces, we can use tains, we can use tolerance. There are n number of stuffs as features available in inbuilt Kubernetes itself, so that we can think of and we can go ahead and secure our sensitive workload. When we are talking about the context inside the container, we can actually use tools that can be used to enhance the container's security by a layer of protection, like AppArmor is there, gvisor is there. These helps us in sandboxing the container to run them securely, and they are not running as other containers run on the host machine. That becomes important. And when we are actually running these many workloads in the cluster, if we go ahead and enable auditing, so who executed what command on which API was called, those things, just monitoring those auditing logs becomes very crucial. So we can go ahead and enable the auditing in our cluster. That also becomes one of the key aspects during the security practices which we think of. So these are a few of the security best practices which I could think of, which we are actually practicing in the production environment. Very important aspect to think why we need to secure the container's lifecycle. Container is like in Kubernetes, security would be important throughout the lifecycle of the container because it is dynamic, it is distributed. The entire stuff is with microservices. It's a distributed architecture. So different security approaches would be required. It's just not safeguarding in one phase or one side would be sufficient. There are multiple phases, right? We build, we deploy, we run our application. So all the phases are quite important. Kubernetes provides security advantages like if Kubernetes has one version of application running, if you want to deploy the other version, you don't patch it. Rather, you go ahead and deploy the newer version of your software. So here we are just replacing the entire thing with a new version. And because of that, sometimes whatever we would have done in our version 1 could not be that we missed that in version 2. So rolling back to the previous version is also pretty easy in Kubernetes. So these things becomes very like crucial aspects, I would say. Version to version, when we are rolling out, we need to have strict version control. We need to permit rapid rollbacks in case the vulnerabilities are not covered in the new version of the code. And when we are talking about pods, and because they are ephemeral, things change very rapidly. And because of that, the APIs, links to the application, the services, there are a lot of constant influx in it. So because of that, the security aspects becomes very crucial. Then going to the last slide, what would be the advantages? Containers are not patched. they are updated. So one aspect is good, that if my previous version was not that secure, I can still go ahead and make my newer version secure, because they get completely replaced each time when we are rolling out. That is one of the biggest security advantages, I would say. And with all these things, network policing, scanning, or cluster security aspects like RBAC, all these things can make our entire Kubernetes cluster, code, cloud, everything together would contribute to the security aspect. It's just not one thing which we would be going ahead and securing it. It would be the entire stuff which we would be securing. So these were a few of the important points which I wanted to highlight from the best security practices aspect, in which all areas you need to focus, what all stuffs you need to take care of, security context, pod-to-pod communication, policing with network policies, RBAC on the cloud level. If we are exposing our nodes to the public, then just be cautious about it. Just securing our APIs, how they are getting called using TLS, that becomes one of the biggest important aspects. So these are a few of the things. If we keep an eye on these stuffs, if we practice this, if we adapt that, we would have a very secure cluster. We would have a very secure application, which we can serve happily to our customers. So this was all from my side. Hope you people enjoyed the session. It was informative. Please be tuned and enjoy the rest of the sessions which are lined up next for you.